Hi, I'm James Nations.
And I'm Bryce Oberman, and today we're going to be talking about cellular respiration with an emphasis on the KREBS cycle. The first step of cellular respiration is glycolysis. This occurs in cytoplasm. In the energy input phase, 2 ATP are added to glucose, causing it to split into 2 3-carbon chains. In the energy payoff phase, another phosphate is added to each of the 3-carbon chains. Now we have a 3-carbon chain with a phosphate on each end. For each of the 3-carbon chains, NAD+ is reduced by the addition of a hydrogen atom as well as an electron to form NADH. The phosphates on the ends of the 3-carbon chains are added to ADP to form ATP. The inputs per glucose molecule are 2 ATP used to start the cycle. This acts similarly to providing activation energy, and this also includes 2 NAD+. In the outputs, for each glucose molecule that enters, 2 NADH and 2 pyruvate molecules form, as well as a net gain of 2 ATP. This is because 2 enter in the energy input phase and 4 are created in the energy payoff phase. The next step in cellular respiration is pyruvate oxidation. This occurs in the mitochondrial matrix and is an intermediate step between glycolysis and the KREBS cycle. As you can see here, CO2 is released, leaving a 2-carbon molecule. Then, NAD+ is reduced to form NADH by the addition of a hydrogen atom as well as an electron. Coenzyme A, called CoA, enters to form acetyl coenzyme A, also called CoA.
The KREBS cycle occurs in the mitochondrial matrix and is also referred to as the citric acid cycle. In the first step, acetyl-CoA combines with oxaloacetate to form citrate, a 6-carbon molecule. H2O is both removed and then added to form isocitrate, a 6-carbon molecule. NAD+ is reduced to form NADH as isocitrate is oxidized, causing a carbon atom to leave and form CO2, leaving a 5-carbon molecule called alpha-ketoglutarate. Alpha-ketoglutarate loses another carbon which forms CO2 as it is oxidized. NAD+ is reduced to form NADH. The CoA molecule attaches to the 4-carbon molecule by an unstable bond, forming succinyl coenzyme A. In succinyl coenzyme A, the CoA is replaced by a phosphate group, which immediately combines with a GDP to form GTP, which is then used to generate ATP. Succinate is oxidized by FAD, which is reduced to produce FADH2. H2O is added to fumarate to form malate. Malate is oxidized by the reduction of NAD+ to form NADH and oxaloacetate. Oxaloacetate combines with another coenzyme A to repeat the cycle. To recap, the net inputs for the KREBS cycle are 1 acetyl-CoA, 1 FAD+, 1 ADP, and 3 NAD+. Now keep in mind, 2 acetyl-CoAs per glucose molecule come out of pyruvate oxidation. The net products of the KREBS cycle per acetyl-CoA is 3 NADH, 1 FADH2, 1 ATP, and 2 CO2 molecules.
The last step of cellular respiration is oxidative phosphorylation. This occurs after the KREBS cycle in the inner mitochondrial membrane. During electron transport chain, NADH and FADH2 are oxidized as the energy-carrying electrons enter the complexes in the intramembrane space. The energy stored in the electrons is slowly released, and H+ ions are pumped across the membrane, creating a proton gradient. H+ also combines with oxygen, the final electron acceptor, to form H2O. During chemiosmosis, ATP synthase is powered by the H+ gradient to form ATP from ADP in a free phosphate group.
Here are our references. Thank you again for watching our video. We hope this video was educational and helped you better understand the complex process of cellular respiration.